we find there lots of types of sediment that are like sediments in modern Antarctica. And so what we see in our sedimentary record then is the last stages of snowball Earth. So snowball Earth means freezing completely. As it comes towards the end, it just starts to warm up slightly, and we have slight oscillations in the climate. And the record that we see on land is just like what we see today in the environments of what they call the dry valleys in Antarctica. Now, these are incredibly arid places where the average temperature is about -20 through the year. There's only about, on a tiny amount of snowfall each year, maybe 10 or 20 centimeters of snow. It's incredibly dry. There are salt lakes there. And interestingly, there is also life. One thing is that the scientists from NASA, when they think about, are there places on Earth that are like Mars, they go to places like the dry valleys in Antarctica to try and find those analogies. So they've had quite an extensive research program going for quite a long time now, looking at the processes, looking at what's happening there, and then comparing it with what we are gradually learning about the planet Mars. So what we can do is to distinguish between environments that are on the Earth's surface and those that are buried. So let's just look at the ones that are on the Earth's surface. That's like, you know, if you walk around on the dry valleys of Antarctica today, then you can walk around, see these salt lakes. During the summer, streams flow for very limited periods of time. And what we find there are microbes living. And these microbes make this kind of sticky mat that covers the surface of the sediment. They photosynthesize, they release bubbles of oxygen, they trap sediment, they can help precipitate calcium carbonate, and we find them in streams, and we find them in lakes in Antarctica. So even at -20 degrees, these microbes are around very happily. Now, this is not the very coldest part of snowball Earth. That's when the planet's frozen completely. But just in the waning stages, that's the kind of analogy that we have in those Antarctic lakes today. But of course, in the winter, if you were to go there in the winter, everything would be completely frozen up. So that's then more like the cold stage of snowball Earth. So seasonally, that environment becomes the really cold snowball Earth. However, we will have some other environments too, because we've also got the subsurface environments. Now, when we think about where are there living things on this planet? Well, we have to think about what's in the planet too. What's in the ice, under the ice, in sediments, in cracks in rocks. And we find evidence of microbes going way down, maybe more than a kilometer down beneath the Earth's surface. So there's a great mass of organic matter over a huge zone there. So back in the 1990s, one thing that we did was to have a look at the base of some alpine glaciers in Switzerland, for example. And we found that there were lots of microbes there, and they were helping speed up chemical reactions. And at that time, that was quite a new thing. But now we know that microbes are doing all kinds of interesting things underneath glaciers, even very thick ones. So if we take Antarctica, for example, there may be 3 kilometers of ice there, but at the bottom, it's actually at the pressure melting point. In other words, the melting point is a little bit lower than it would be on the Earth's surface because of the pressure of ice, but there is liquid water there. And in settings like that, one would certainly expect microbes to be present, and they would feed on ground up rock, on the organic carbon in ground up rock in those situations. So in the subsurface, we certainly recognize lots of microbial life being present. Now, on Mars today, of course, the surface of Mars is really cold. No liquid water on the surface normally, but actually people who've been watching the surface of Mars find that just occasionally a whole mass of sediment just cascades down slope. And one of the theories for that is that there's some melting of ice underneath the surface, allowing the sediment to flow freely. And certainly in the past, there were lots of rivers and lakes. You can see the signs of them all over the planet. And we know that there's a lot of carbon dioxide ice and water ice at the poles in Mars. So it's really quite plausible that if life had evolved on Mars, that it would still be there, hiding underneath the surface.